In a different video, I discussed and made a solution to the following problem. Two children who are bored while waiting for their flight at the airport decide to race from one end of the 20-meter-long moving sidewalk to the other and back. Philippe runs on the sidewalk at 2 meters per second relative to the sidewalk, and Renee runs on the floor at 2 meters per second. The sidewalk moves at 1.5 meters per second relative to the floor. Both make the turn instantly with no loss of speed, and you're asked who wins and by how many seconds. And in the problem, I went through and it's fine, but I kind of quick and dirty came up with the speeds we had to use, and now I want to think about it in greater detail. So I'm just going to focus at the moment on the time that Felipe takes to go the first half. Because remember, what we want here is the round trip times, and that's the first thing. And the round trip time, of course, would be the time from one end to the other, given that this is moving at 2 meters per second. And that Felipe runs at 2 meters per second. This is not 2 meters per second. This is 1.5 meters per second. Otherwise, the math would be suspiciously convenient. And we have to give our standard names to these things. So I'm going to call this the velocity of the walkway with respect to the ground. And I call this is the velocity of Felipe relative to the ground. But what we want is how long it takes Felipe to travel, in this case just one way, 20 meters. And the idea is I find that time, and I'd add how long it takes for him to go back, and that would be his total time. And I could do the same thing for Renee. Oh, for Renee it's easy because he's not moving. So we'll just go with this one at the moment. Because the 20 meters is measured relative to the still ground, if I want to figure out the time, and in general I would say that the time that Felipe takes, let's say downstream, right? That would be the distance over the speed. Coming from our base definition that velocity is distance over time. But since I'm measuring relative to the distance relative to the still ground, I have to use the velocity relative to the still ground. So this would be the distance L over Felipe's speed relative to the ground. And you'll notice I don't have that. So I go back to our standard vector equation, and we say the velocity of Felipe relative to the ground can be considered the sum of two things. His velocity relative to the walkway added to the velocity of the walkway relative to the ground. So the thing that I want, which I'll call his VPG in this direction, is 2 meters per second in that direction, plus another 1.5 meters per second in that direction. And we see that that, of course, comes out to be 3.5 meters per second in the same direction as the thing we were looking for. So that was why I was able to say, let's call this the downstream direction. I was able to say that it was 20 meters over 3.5 meters per second, which is 40/70ths meters of a second. And that's fine. And then we could say that the same sort of thing would happen the other way. So we would have Felipe's time upstream, which would again be L over, and now I'm going to give it a different name, so I'm going to call it like a star or something. And I'll say that his speed downstream is still, right? We use the same equation. Oops. And now we would say something like the speed that I want heading that way equals 2 meters per second heading that way, plus still 1.5 meters per second heading the original direction. And we see, well, when I add this thing, I can treat that thing as, so we can think of this now as 2.5 meters per second upstream plus, and I can think of it as minus 1.5 meters per second upstream. And so we get what I had before, just half a meter per second upstream. And so now we have over here the 20 meters over a half meter per second, or 40 seconds, as done before in the other video. Of course, for Renee, we don't actually have to go through all that rigmarole. In both cases, the speed is just 2 because the thing he's running against is the ground, so it's already set.